Okay, here's a rather interesting problem. Seems like it's kind of out of the blue, but why don't you read this and see how you would apply energy to solve this problem. Okay, so pause the video and give it some thought. Okay, to do this, I would apply conservation of energy to the part that is getting warming up. Okay, so if you think about the work that's being done, there's no expansion, there's no heat transfer because it occurs so fast. There's no way you can get any heat out of there. So there's really no energy going in or out of the hand and face. And so the left-hand side of the energy is zero. There's nothing being added. There's nothing being taken away. So the zero is going to equal the final energy that you have minus the initial energy. So in the final energy, since it's a solid, we're going to use the equations for internal energy for a solid, which would be the mass times the specific heat times the temperature at the end. So that would be mass times CV times temperature 2. So whatever warmed up, that's the mass that you take. Okay, and then you subtract, because the initial energy is whatever tissue it was, M of the, I'm calling it face for face, but it's whatever the system is. So it's the face tissue times the C and the original temperature. Okay, and also at the beginning you have some kinetic energy in the hand. So that would be this part right here. So this is the kinetic energy, 1/2 mass of the hand, because the face isn't moving. So it's only the mass of the hand times the velocity squared. So that's the energy equation. Okay, so now think about it and see if you have all of the values that you need. How will you solve it? Give it some thought and pause the video. Okay, so basically you have everything that you need. You're given the mass, you're given the temperatures. Now, if you notice, there's 2 temperatures. So what are you going to do about the 2 temperatures? You're only given a temperature rise. So give that some thought and pause the video. If you notice, the 2 temperatures are both multiplied by the same quantities, mass times CV. So really, it's this thing is going to reduce to T2 minus T1, which is the temperature rise, which is 2.4. So you know even though you don't know the initial temperature, you really only need to know the change in the temperature. Okay, so from this you can just plug numbers in and calculate things. Make sure that you use the right masses. So the mass of the face was given as 0.15, and that was kilograms. The mass of the hand was given as 0.9. So you just take these numbers, plug them in, and calculate the velocity. So pause the video, make sure that you can make the calculations. Okay, so the correct answer is the velocity is equal to 55.1. So the question is, what are the units that are on this? So give it some thought and I'll get back to you. Because we're using standard units, that's why we made this 3800 and not 3.8. Because we're using standard units, this will be in the standard unit too. Velocity would be meters per second. So this is meters per second. That's it for this one.